Hello everyone. So far we discussed until MVC architecture. Up to MVC architecture we discussed. MVC architecture we have discussed. Right. Now in this session we are going to start the first concept of advanced Java. What is that? Databases. We'll discuss more about databases. First thing, yeah, databases, JDBC API. Sorry. Yeah, okay. We'll talk about JDBC API. First, before going to JDBC API, let's talk about databases. Let's talk about databases. What is a database? What is database? And what is the need of it? What is the need of database? We have lot of database systems. We have lot of database systems in the market. Why we need them? Why we need use database softwares like Oracle database, Oracle providing a very famous database, Oracle DB, MySQL, open source database, Postgres, Cassandra, MongoDB. There are so many like such. There are so many databases, hundreds and thousands of databases. Why we need these database softwares? Okay, basically the database image is this one. Everybody will refer this image for database. Okay, whenever you see image like this, you can consider it as a database. This is the basic diagram for database. Okay, so what is the purpose of databases? Databases are useful to store data securely. The use case. What is the use? What is the use of it? What is the use of any database? Data storage. Data storage. Which data storage? And how it will store any data which you want to store, which you want to store, it will store in a structured manner. Which kind of data we can store? A structured data we can store. Structured data. Structured data we can store. And easy to scale. Easy to scale. Whenever we see that large data is coming, I want to increase the size. It is easy to scale. Security, nobody will access your database. If you have permissions, only you need to access it. If you share permissions with others, then only they can able to access it. Databases are high in security, and many users can access concurrently. Concurrency, you must have heard this word, right? Concurrency. Many users can interact with this data structure. Let's imagine there is a sale going on. There is a sale going on in Amazon. We everybody log into application, same application, and we will try to search for the same products. Let's say if they give offer, right? Maybe by end of this year, they may give offer iPhone 15. Okay, they may say we decreased price up to 25% or 50%. Everybody will search for that same product. Everybody will try to place order for the same product. So when we all try to access at a time, your databases need to support, right? So databases concurrency support also we have. Many users can at a time interact. They can read data, they can write data, right? So this is not possible, sir. Data we can store in files also, na, sir. We can use simple file in Notepad also we can store. I can use simple file system also, na, sir. Notepad in a text file, in a text or CSV file, comma separated values. I can store this data, na, sir. Yes, you can store the data, but your data is unstructured. When you use text based file system, right? That is we call unstructured. Unstructured. We don't know what kind of data is coming into this file. But if it is a database table, compulsory, whatever columns we have mentioned, let's say if I mention name, email address, or if I mention product ID, product name, product color, price, only those details only I need to save here. But when it comes to text file, you don't have any such control on this file. Unstructured data we will be putting it unstructured data. And scaling is not possible. Scaling is not possible because it is a file system. Scaling is not possible. If your disk, if a disk size is completed, you utilize the complete disk space. So you can't scale it up. You cannot scale it up. You cannot able to scale it up. And file systems are not secure. Files are not secure. Anybody can access. Anybody can access. So no security. So there is a security problem also. Everybody can open your file and see the data. And concurrently, many people may not able to access. No concurrency. No concurrency. Why people are referring databases means these are the reasons. If I go with file system, my data is not safe. My data is unstructured. My data is not possible to scale. My data is not secured. My data is not concurrent. That's the reason people prefer to use databases. That's the reason people will prefer to use databases. Databases are powerful components for the data storage. Okay, so that's why we use databases rather than file system. Sir, don't we use file system in any applications? Means we will use file systems. We will use file systems for what purpose? For images, audios, videos. If you have any such data, that is okay. Sir, I have images, so I need to refer file system only, sir. Okay, that I will agree. Images, audio files, video files. If you have all such, you can go with the file system. You can go with file system. There is no question about it. Databases we will use for structured data. If there is any, if there is any file, large volume of file, if you want to use, we can use file system. Database systems we will use for to store the structured data. To store the structured data like employee information, account information, product information, right? Information properly we can save in the databases and easily we can able to scale it up whenever we want. And security, high security database systems and concurrency, many people can access at a time your database. It will not create any issues or any crux, but whereas file system will create a lot of issues if I go with that. The same comparison I just have noted here, please try to understand. Okay, file system is hierarchical directories, so it is not structured, whereas database is structured. Tabular format we will use, tables, rows, columns. Such concept we will use. Such concept we will use. When it comes to file system, we just create folders and files. That's it. We can create directories inside. We can create more files. We can create more folders like that. We can use data access. Coming to data access, file paths and names, by using name or file path we can able to access it. But when it comes to database data, using SQL queries we will get that information. It is not direct way to get any information from database. We need to use queries. By using SQL queries only we can able to read the information from database. So it is not easy to someone go and read the data. Okay, so technical people only can able to apply this SQL queries and able to read data. And file system is unstructured. File system is unstructured, so there is no structure. If I ask, give me who are all the which employees having the salary greater than 500 or something, if I mention 5,000 or 50,000, if I mention, it will be difficult to you. You can't able to identify where that salary is. But when it comes to database, it is easy. As it is a structured database, it is easy to find out where it is. Okay. And scalability. Scaling wise, file system is limited. So I have some 100 GB SSD hard disk. That 100 GB is completed. That's it. You need to install extra hard disk. You need to go to market and you need to install extra hard disk. Automatically, you can't scale it up. Maybe you need to shut down your application. By that time, your data may lose. But the databases are highly scalable. Automatically, you can scale it up. So already 25 GB of my database is consumed. Do I need to shut down my database? And do I need to buy another database which is having 50 GB? Not required. Automatically, database providers will provide you this scaling support. Automatically it will increase the size of your database. Concurrency, basic file locking may be possible. For each file you may put file locking, but it is not possible to maintain files concurrently. But whereas databases will maintain advanced level of transactions to maintain your data safe, and on data you can apply logs also. So it is very concurrent database, whereas file systems are not concurrent. And backups, if I want to take manually you need to take backups, you need to copy your data and you need to paste it somewhere. But when it comes to database, automatic backups are possible. Automatic backups are possible when I use a database. Okay. And searching queries, there is no search query concept in the file system, but we have searching queries concepts in database. So powerful, and they will execute very faster rather than file system. That's why people will prefer databases rather than file systems for any applications. Okay, so this is the foundation of databases. Okay, on top of it we will learn JDBC. On top of it we will learn JDBC. I'll show you simple queries. Okay, simple queries in a few steps I'll show you in databases. Okay, database queries are basically three types. Okay, majorly three types: DDL queries, DML queries, and DRL queries. DDL, DML, DRL. We will divide into three separate queries. Okay, three types of SQL queries we have. So what is DDL queries? Are data definition language, which means how to create a table, creating table or delete table, right? All these concepts we will have in DDL, creating table and deleting or dropping the table. We call it drop actually, dropping tables or renaming the table. We call them DDL queries. Renaming the table, all this we call DDL queries. Whereas DML queries are useful for data retrieval. Data retrieval queries we will write by using DML. Sorry. Data retrieval is for DRL by using DML. Data manipulation. We can able to do what kind of data manipulations? You can able to insert data. You can able to update data in tables. Insert, update, delete, all such we can apply. Delete data, all such we can apply by using DML queries. You can insert some data, you can update some data, you can delete some data. All that are possible with the DML. So whatever data you have inserted, whatever data you have updated, if you want to retrieve, we will go with DRL, data retrieval. We call them select queries. Select a star from table we will use, right? So those are the select queries. For example, for DDL, if you want to see, already installed MySQL database. Let me open it. I have MySQL database and Oracle, many databases I have. Let me open MySQL database. It is asking for password. I entered password. Now I'm asking for show databases. So it will show all the available databases. Okay, customer database, information database, MySQL, products. I created a few databases. Few are default database schemas. Few are default. Few I created. Seller, products, customer. I think I created them. So if you want to create your own database, you can create database, my tested DB. You can create query. Okay, one row affected means one database is created. Now you need to use database. Use my test DB. Database changed. So now you started using my test DB. And if you want to see all the tables, you need to call show tables. So it is showing empty set. There is no table. Now if you want to create table, you can create here. I hope my screen is clearly visible, right? So I'll show you how to create a table here. Simple table I will create. Okay, and I'll execute it. Okay, simple table. Create table student. Create table student. ID, int, name, varchar, size I am giving, email, varchar. Again, size I am giving. That's it. Simple. Create command is create table student ID data types. ID is number data type. So that's why I given int. Like Java only. Int we are using here. Right? For names, we are using varchar data type. For names, we are using varchar data type. For integers, for numbers, I used integer. So create table. So it is showing query okay. Table is created. Now next query is DML. Inserting, updating, or deleting. How you will do? Now insert data. Insert into student values. And you can give values here. Student ID 1 is name. Student ID 1 name. Pavan. And his email. pavan@gmail.com. Enter. Query okay, one row affected, which means one row recorded. One row is saved. So if you want to see that saved data, you can see it. I'll show you. So now by using this insert query, I have inserted data. So this is a DML query. By using insert query, I inserted data. Now if you want to retrieve it, we will use DRL query. We will use a DRL query. We will use a DRL query. We will use a DRL query. So I went to my database. There I will apply this select star from student. Select star from student. When I apply this query, you can see it is showing me data in a tabular format. It is showing there is one row. It is showing in a tabular format. It is showing the data in tabular format. So this is what DRL is. This is what DRL query is. This is what DRL query is. This is what DRL is. See how simple to use SQL. Basic queries only, right? So if you learn these queries, that's enough. Basic queries, how to create, how to insert, how to select. These all are the basic standard queries, okay? If you go anywhere, sir, is it different in Arkle? No, almost everything is same except data types. All such will change, that's it. Only data types will change. Remaining structure is almost the same. Okay, so I'll show you a couple of examples in Arkle and a couple of examples in MySQL going forward. Okay, so we will discuss JDBC in the next session by using this database concepts. Okay, today what we will understand: what is database, who all are providing databases, what is the difference between database and file system, right? And we understand all the major differences of file system and databases. We understand all major differences between file system and databases, and we understand what is DDL, DML, and DRL, right? Hope this concept is very clear. Just repeat this video if you have any doubts, okay? And watch it again. Thank you.